In this section, we are going to talk about binomial theorems. So the whole point about the binomial theorem is that there is a formula that exists that will help us expand binomials. So let me give you an example. So let's say I wanted to expand a plus b to the 0 power. Well, we know that anything to the 0 power is just going to be equal to 1. So that's easy. Now, what about if I had a plus b to the first power? Well, I'm not really foiling anything. I'm just going to have a plus b, nothing. Okay, what about if I had a plus b to the second power? Well, this means I'm going to be foiling out a plus b times a plus b, and I'm going to FOIL everything out. And when I FOIL everything out, I'm going to get a squared plus 2ab plus b squared. Now, what about if I had a plus b to the third power? Well, same thing. I have 3 of them now, so I'm going to FOIL all that out, and when I FOIL everything, I'm going to get a to the third plus 3a squared b plus 3ab squared plus b cubed. And I can keep doing it for many different powers. So when I raise it to the 4th power, I'm going to get a to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th power. And I can continue doing this for every single type of number. So let me just do one more. This is going to be a to the 5th power plus 5a to the 4th b plus 10a cubed b squared plus 10a squared b cubed plus 5ab to the 4th plus b to the 5th. So you're probably wondering, why the hell are we doing this? So why are we doing this? So we want to figure out if there's a pattern that will make it easier for us to do instead of foiling all of this out. Because it's kind of tedious just to FOIL out every single term, and it's really easy to make a mistake. Because we can do this for many things. So let's look at a couple things that we notice. Okay, so a couple things that we notice is that if you look at, for example, a plus b to the 3rd power, look at the values of a. We start off with a to the 3rd power, which is basically this third. Then what happens to the a? Well, now it's a to the 2nd power. What happens to this a? Now it's a to the 1st power. And then there's no a. Now what about the b term? There's no b, 1b, 2b's, and then 3b's. And notice that that happens for every single power. A plus b to the 4th power, this one has 4a's, 3a's, 2a's, 1a, no a. No b's, 1b, 2b's, 3b's, and 4b's. So notice that whatever the power is, right, the first term, okay, so you're continuously decreasing. So the first variable, and I'll just call it variable, decreases by a power of 1. The second variable, which is in this case our b term, increases by a power of 1. Okay? Now, what do we notice about each term? If you look at each term, a to the 4th, well, that's just 4. Look at these numbers, a to the 3rd and b to the 1st power. Well, if I were to add those, that also equals 4. If I were to add a squared and b squared, add the exponents, I also get 4. Same thing here, I also get 4, and then 4. So the sum of the exponents of each term is equal to the power that I'm raising it to. Okay, so and now that's okay. Okay, so how do we get the numbers though? Because everything seems good. I think that I can probably FOIL everything out, because I know that the first number is just decreasing, the second number is just increasing. But how do I get these numbers, like 3, 3, and 1, and 4, and 6, and 4? How do I get these numbers to appear? Well, there's something called Pascal's triangle. And this is what Pascal's triangle is. So the first thing that I'm going to start off with, I'm going to start with the number 1, and then 2 other ones afterwards. So you have a 1 and then 2 other ones. So on the diagonals, I'm just going to have 1s. Okay, nothing's really going to happen. In the inside, it's going to be the sum of these two numbers. 1 plus 1 gives me 2. Now I'm going to start another one, another row. So I'm going to add another 1. Here, 1 and 2 is going to give me 3. 2 and 1 is going to give me 3. Right? Then I'm going to add my next column. My next row. 1 and 3 is going to give me 4. 3 and 3 is going to give me 6. 3 and 1 is going to give me 4. So all I'm just doing is just adding each of these. So these things I'm just adding. I'm adding the numbers. Okay, so what do you think this one's going to be? 1 and 4 is going to give me a 5. This and this, 4 and 6 is going to give me 10. 6 and 4 is going to give me 10. 4 and 1 is going to give me 5. Do these numbers look very familiar? Well, these numbers are actually the coefficients of these numbers. 1, 1, 1, 1, 2, 1, just like how we had this one. 1, 3, 3, 1, which is this one. Oops, not that one. Yep, and then the other one, 1, 4, 6, 1. And then the other one, 1, 5, 10, 10, 5, 1. So Pascal's triangle actually gives us the coefficients of the binomials. Okay, so do you think that you can try to figure out some other binomials? Now that we know this, can we try to figure out a new problem? Can we try to figure out this? Expand x plus y to the 6th power. So what do you think that's going to be? Well, the first thing that we're going to do is that we're going to start off with the x's. The x, if you look at all the a values, the a always started off with the power. So we're going to start off with x. X is going to start off with a 6. Then x is going to decrease. Okay, it's going to be x to the 5th power. Then x to the 4th power. X to the 3rd power. X to the 2nd power. Then x. And then no x. So it's going to be nothing there. Now what about the y? There's first going to be no y there. Then you're going to have 1y, 2 y's, 3 y's, 4 y's, 5 y's, and then 6 y's. Okay? And now how do we do the coefficients? Well, notice here, the way that we're going to get the coefficients right in front of it. This one, imagine that this corresponds with row 0. Okay, let me write it again. So we have 1, 1, 1. This one's going to correspond with row 0 or power 0. So if you have something raised to the power of 0, it's just going to be 1. This is going to be raised to the power of 1. And let's just create more of the rows. 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. So this is power 0. This is going to be power 2. This is going to be power 3, power of 4, power of 5, but we want a power of 6, so we got to do one more row. So this is going to be 1. 1 plus 5 gives me 6. 5 plus 10 gives me 15. 10 plus 10 gives me 20. 10 and 5 gives me 15. 5 and 1 gives me 6, and then I'm going to have a 1. So this is going to be my coefficients of my expansion. So we're going to start off with a 1, then we're going to have a 6, then we're going to have a 15, a 20, a 15, a 6, and then a 1. And since this is a positive, I'm just going to have a positive in there because everything is going to stay positive. So this is my expansion, which is much easier than having to FOIL everything out many different times. Okay, so let's do another problem that's a little bit more involved. Okay, so now that we know what it is, so basically we know that the first variable is going to decrease. It's going to start off with a power, and then it's going to decrease by 1. The second variable is going to be increasing by a power of 1. So they basically are in the opposites. So let's do another problem. So expand the following. Expand 2x plus y to the power of 3. So let's expand something that looks like this. Now notice there's a 2 there. Okay, so what are we going to do with that 2? So we have a 2. All we're going to do is now this whole thing is now going to be my new x. So this whole 2x is going to be raised to the power of 3. Then it's going to be 2x raised to the power of 2. 2x raised to the power of 1. And then no afterwards. I mean, you can write it if you want, 2x raised to the power of 0. That way you don't lose your placement. Now what about my y? My y is going to start off with none. So there's none in the beginning. Then there's 1. Then there's 2. And then there's 3. Okay. And now what are going to be my coefficients? Well, my coefficients is to the power of 3. So to the power of 3 is going to be this one. 1, 3, 3, 1. So this is going to be a 1, a 3, a 3, and a 1. Okay, now let's add everything up. Okay, so this is going to be 2x to the power of 3. Y to the 0 power is just 1. 3, 2x squared. Then there's 1y. Plus 3, 2x, y squared. Plus, this is just going to be equal to a 1, y cubed. So notice you didn't really have to add this y to the 0 and 2x to the 0 power. But you can just leave it there if this makes sense to you. Okay, now we got to distribute this 3. So 2 to the third power is going to give me 8, then x cubed, plus 3. 2 to the second power is going to give me 4, x squared times y. This is just to the power of 1, so that doesn't really do anything. This is going to give me 6xy squared, and then plus y cubed. So now let's just finally multiply everything. 8x cubed plus 12x squared y plus 6xy squared plus y cubed. This is going to be my final answer. So you do have to do a little bit more work when you have terms that look like that. All right, now let's do one last problem. So what do you do when you deal with problems that have a minus? And notice that I'm doing it to the power of 3 because if I do anything to the power of 4 or 5, it's just going to be really, really long. So 2x minus 1 to the power of 3. So let's expand this. So let's start off with a 2x. So we're going to start off with 2x to the power of 3, 2x to the power of 2, 2x to the power of 1, and then 2x to the power of 0. Okay, now we're going to do that y. Now that y is now a negative 1. We're going to include that negative. So the first one's going to have negative 1 to the 0 power. Negative 1 squared. Oh, not squared, 1. Negative 1 to the first power. Negative 1 to the second power. Negative 1 to the third power. Okay, so we did our x's in decreasing order. We did our y's, which in this case was negative 1, in increasing order. Now, since it's to the power of 3, we're going to use this row for our coefficients, 1, 3, 3, 1. So this is going to just be 1, 3, 3, 1. And let's just add everything up. So this is just going to give me 2 to the third power. It's going to be 8x cubed. This is just going to give me 1 plus 3. This is going to give me 4x squared. Then you have a negative 1 attached to it. This part is just going to give me 6x. And then negative 1 squared is just going to give me a 1. this is just going to give me a 1 times a 1. This is going to give me this negative 1 to the third power is going to give me a negative 1. So my answer is going to be 8x cubed. This is going to be a negative 12x squared plus 6x minus 1. This is going to be my final answer. Okay, so here is a way that you can do it. It does involve a little bit more work, but this is just what's gonna what you're gonna get. Now you could have easily done to any other power. It's just that it gets a lot more messier.